In this video, I'm going to show you how to solve the ALEKS problem called naming and drawing alcohols. There's two versions of this problem. In one version, you're going to get the structure of 3 alcohols and you're asked to come up with the names of each of those alcohols. Another version of the problem, you're going to be given the name of an alcohol and you're going to be asked to draw its structure. This is the version of the problem that I'm going to work out for you today. Whenever we're being asked to name a molecule, our first job is to find the longest continuous chain of carbon atoms that contains the functional group that we're working with. So in this case, we're working with alcohols. We're looking for the longest chain of carbon atoms that includes that alcohol functional group. Step number 2, we would need to number the chain of carbons so that the alcohol functional group is placed on the smallest possible number. In this case, number 1. We don't want to number the carbon chain in this direction because that would put the alcohol functional group on carbon number 5. We want it on the smallest possible number. Now we're ready to name the molecule. We're going to start by locating and naming our substituent. On carbon number 4, we have a methyl group. Next, we're ready to name the parent chain. The parent chain of this molecule has 5 carbons, and the suffix for 5 is pentane, is based off of pentane. This is not pentane. Pentane would be just 5 carbon atoms without the alcohol present. When there's an alcohol present, we're going to indicate that by dropping the E from the molecule's name and replacing it with OL for alcohol, all. So this is a pentanol. Now that's not the end of it. We can't just change the ending and that's enough. We also have to say where the all is located. The all is located on carbon number 1, and we're going to put that in front of the alcohol's name. So this is going to be 1-pentanol, and if we break this name down, what we're saying is that we have a 5 carbon chain. It has an alcohol on carbon number 1, and also it has a methyl group on carbon number 4. Let's try it again with our next example. This one we have a cyclic molecule, a 6-membered ring. That's going to be a cyclohexane. And we want to number that ring so that the alcohol gets the smallest possible number, so it's carbon number 1. Now we're going to number either clockwise or counterclockwise around the ring so that our other substituents also get the smallest possible numbers. So there's one option, and in this option, our substituents are located on 3 and 5. We also want to think about the possibility of numbering in the counterclockwise direction. I'm going to do that in a different color. In this option, our substituents are located on 3 and 5. It's like a tie. If we go one way, we have 3, 5. If we go the other way, we have 3, 5. What are we going to do in this situation? When we have a tie, we're going to break that tie using the alphabetical order of the substituents. So we need to think about our substituents' names. This guy down here is methyl, 1 carbon substituent. And then this one up here, a 3 carbon substituent, is propyl. Alphabetically, methyl comes first before propyl. And because of that, we're going to go ahead and give methyl the smaller number. So that means we want methyl to be on carbon number 3, and we're going to be using this numbering system that I drew in red. So in the case of a tie, which is what we experienced here, in the case of a tie, we're going to break the tie by going with the alphabetical order of the substituents' names. Now we're ready to put it all together. We have a methyl group on carbon number 3. We have a propyl group on carbon number 5. We have a cyclohexane, except it's an alcohol, so it's a cyclohexanol with our alcohol on carbon number 1. Now our last example down here, this one's a little bit unique because if you're looking at it carefully, you're going to see that this one has 2 OH groups. This is a dialcohol. It's got 2 OH groups. First, we're going to find the longest carbon chain, which I already did. And then next, we're going to number that carbon chain so that the alcohols, the OHs, are on the smallest possible set of numbers. I've got it numbered so that they're on carbons 1 and 2. Now we're ready to locate and name our substituents. And we have 3 identical substituents. We have 3 methyls, which is a trimethyl. We need to locate each one of them. We've got 1 on carbon number 2. We've got 1 on carbon number 3. We've got another 1 on carbon number 3. So it's 2, 3, 3, trimethyl. Now we're going to say the name of our parent chain, 4 carbons. That is a butane. And if this was just with one OH group, we would call that a butanol. But this is 2 OH group, so it's a little bit different. When we have 2 OH groups, we're going to call this a diol. Di means 2, and then as you know, ol means alcohol. So butane, that tells us that we have 4 carbons. Diol means that we've got 2 OH groups, and of course we need to say the location of both of them. 1, 2, butane. Now, butane diol. Now you're probably stressing out because I didn't drop the E in this molecule's name. I dropped the E in every other molecule's name. This is not pentanol, it's just pentanol. And that is not a mistake on my part. This is how IUPAC wants us to name these molecules. When you have a diol, you do not get rid of that last E. If it's not a diol, then you do get rid of the E. But when it's a diol, you leave that E there. And I honestly don't know why. I think probably it's just because that's kind of an awkward name. And we need that E present to keep it from being awkward.